So, something that I neglected to mention, but I feel like I should, is that the other half of this counting pattern in multiplication is also the only other instance where it works, right? So, we showed that 56 is 7 times 8, which at one point I said 78 because I was speaking quickly, but I also said it 47 times. So, whatever. I said it correctly like a bunch of times. So, this shouldn't be a point of confusion. However, it's also worth noting that 12 is 3 times 4. And now you have the entire sequence 1, 2, 3, 4, 5, 6, 7, 8. These two multiplication facts should be the first ones that students ever learn. Actually, these should be the anchor points. One of them is halfway to 100, one of them is a little bit over 10. These are both very useful anchor points, and they are the easiest to remember. And it is not inappropriate to just immediately teach these to kids right after they've learned how to count and are comfortable with the order of numbers. And you can see that the other ones aren't going to work because this one is too small. 23 is prime. 34 is 17 by 2. 45 is 5 by 9. So we got 56. So the next one would be 67, which is prime. And then 78 is too large. Right? Because now, if you're going 78 equals 9 times 10, well, 1 is not true. But also, you have the wrong number of digits. Or, if you go the other way, 5 times 6 is way smaller than 78. So 78 is too large. 0, 1 is too small because now you get 0, 1 equals 2 times 3. Obviously, 2 times 3 is much bigger than 1. So 0, 1 is too small. 7, 8 is too large. And everything in between, it's either prime or its factors are just radically different from anything in a sequence. So, literally, the only ones that work this way is the sequence 1, 2, 3, 4, 5, 6, 7, 8. And they work the same way. The smaller pair, the 1, 2, and 5, 6, equals the other pair multiplied together, 3 by 4 and 7 by 8. 56 is 7 times 8, 12 is 3 by 4. 3 times 4 is 12. 12 is 3 times 4. 1, 2, 3, 4. 56 is 7 times 8. 7 times 8 is 56. 5, 6, 7, 8. And those are the only ones where that's true. There's absolutely no reason for this not to be part of standard pedagogy. It's just right there. It's super easy. Very nice introduction to really a lot of concepts right off the bat that are super easy to teach to kids in like first grade, right? Just remember this for now. 12 is 3 times 4. 1, 2, 3, 4. And 56 is 7 times 8. 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Boom. And now you have an anchor point halfway to 100. It's literally halfway to 100 from 12. It's exactly halfway to 100 from 12. Look at that. Isn't that beautiful? This is something that should just be there. It should just be casually presented to every student. This is nice. It's not groundbreaking. It's not earth-shattering. But it does fill this weird hole of what is 7 times 8? Why is it 56? I have to stop and think about it. It does fill that hole. And it can actually kickstart your math career in a much nicer way, more comfortable way than what we are currently doing.